Greetings to all in Dr. Abha Chemistry Pathshala. Let's begin with our journey of aromatic alkenes, arenes or benzene. So see, method of preparation of benzene में हम बड़ी common सी reactions use करेंगे which we've already done. So and we'll try to prepare benzene. सबसे simple reaction which we've been doing for the preparation of alkane, if you remember, that is decarboxylation reaction. So right, remember, so decarboxylation was removal of a carboxy group, and we were using soda lime, exactly the same reaction, only the alkyl part will be replaced by the aryl part. So और ऐसे ही हमको थोड़ा सा हेलोअरीन्स का रिडक्शन करेंगे, सल्फोनिक एसिड से हम बेंजीन को बनाएंगे. So कुछ बहुत सिंपल सी रिएक्शंस हैं जिनको हम यूज़ करेंगे बेंजीन को बनाने के लिए. एंड लेट मी टेल यू, यहाँ से आपका aromatic का reaction start होता है actually, you know. So and guys, my sincere request would be, every reaction which we are doing, you know, please try to understand what kind of mechanism is taking place और किस तरह के बॉन्ड्स टूट रहे हैं, इलेक्ट्रोफाइल आ रहा है, न्यूक्लियोफाइल आ रहा है, फ्री रेडिकल हो रहा है. क्योंकि बिकॉज एक बार हमने ये चीज़ें समझ ली तो हमें 12th में आपको बहुत ईजी हो जाएगा. सो दिस इज अ चैप्टर, this chapter is from class 11 and soon I think we'll be starting with a series in class 12 and आपको यही understand करोगे कि ये सारी की सारी reactions बहुत ही repetitive है, बार बार इन reactions का ज़रूरत पड़ रहा है. तो एक हम use करेंगे Grignards, although NCERT में नहीं है, but I'm really tempted to share it with you because in 12th we have to do it. So one preparation I'm taking with the help of Grignard reagent, and rest most of the reactions which are there in your NCERT will be discussing them. आपको याद आ रहा है हमने alkynes का polymerization करके बेंजीन को बनाया था, और एक बहुत ही अच्छी important reaction आपने करी थी again alkanes में, Wirth reaction. We can use Wirth reaction to prepare benzene derivatives also. Friedel-Crafts एक बहुत important अपने आप में concept है, named reaction है, उससे हम benzene के derivatives को prepare कर सकते हैं. तो let's not waste time and quickly dive over to the screen for a better explanation.
Let's get started with method of preparation of arenes, that is benzene and its substituted derivatives. Look at the flow chart. First is we'll use decarboxylation, then we'll be using reduction, then we use Grignard reagent. This is not given in NCERT, but it is used in class 12 and it is there in class 12 NCERT. So I think it is more meaningful if we study Grignard in grade 11. Then we use Fittig reaction. Wirth Fittig and Wirth Fittig are very common reaction to prepare hydrocarbons. And then we'll be doing Friedel-Crafts to prepare benzene derivatives. Aromatization, we've already done aromatization in alkane. Trimerization, we've again done it in alkynes. And benzene sulfonic acid, the steam hydrolysis will give you benzene. So quickly let's start these reactions one by one. We take sodium or potassium, we take sodium salt of benzene, treated with soda lime. Soda lime is nothing but a combination of NaOH in presence of calcium oxide. It decarboxylates to give you Na2CO3 and you get benzene with Na2CO3. So this hydrogen is placed on this card, right? So this hydrogen, this one will be placed here to give you a benzene ring, right? This is also the lab preparation of benzene. This is also taken as the lab preparation of benzene. We use various reduction methods to get benzene, starting from phenol. This is phenol, and we take zinc dust, small granules of zinc, and at a very high temperature where the distillation is possible, what happens is zinc will combine with O to give you ZNO. And this H will be substituted in the benzene ring to give you benzene. We can also do reduction of chlorobenzene. If we take any source of nascent hydrogen, we can take nickel and aluminium alloy. In NaOH, we can take lithium aluminum hydride also, and this nascent hydrogen reduces benzene and HCl is the byproduct. There is one more reduction process where we take benzene diazonium chloride, where we take the salt, benzene, this is the diazo group, diazonium cation, and this is the chloride anion. We treat it with H3PO2 in presence of water, and what we get is, guys, diazonium is a very good, nitrogen is a very good leaving group, so easily breaks. Otherwise it is very difficult to break anything from benzene ring because of resonance. So this gets removed easily, and what you get is a benzene here, and you get N2 and HCl and H3PO2, it gets oxidized to H3PO3. You can use the same, you can get benzene with the help of ethanol also. Instead of using H3PO2 and water, you can use ethanol, and instead of H3PO3 you will get ethanol. It will get oxidized from Grignard reagent. Grignard is alkyl or allyl magnesium halide. So now since we need benzene, so I'll have to take aryl, right? So this is phenyl magnesium halide. I can take bromide, I can take chloride, put it in water. This has got a positive charge, this carbon has got negative, chlorine has got negative. So OH has got negative and this has got positive. So what will happen is, this will get combined with this one, right? So you get magnesium hydroxy chloride and you get benzene. Let's move on to the next one. Phytic reaction, we take aryl halide treated with sodium in dry ether, and what we get is, we get biphenyl, or IUPAC name will be phenylbenzene, which is a benzene derivative. This is phytic, where we take purely aromatic. We can use Wurtz phytic also, where we take aromatic and aliphatic derivative in sodium and dry ether. So you get toluene, you get biphenyl, and you get ethane. So what is actually happening is, this is giving with this phytic, this is giving with this Wurtz phytic, Wurtz, and then you are getting a combination which is Wurtz phytic. Let's move on to the next one. So it's a very convenient way to get benzene derivatives. You have benzene ring and this undergoes electrophilic substitution in alkyl halide in presence of anhydrous AlCl3 to give toluene. So similarly we can get other derivatives as well. We can use ethyl, we can use propyl to get isopropyl benzene, and other derivatives can be prepared. Let's move on to the next one, aromatization. Here we've done this in alkane, we take any aliphatic alkane, 6 carbon or more. Suppose we take N-hexane. So this is your N-hexane, and we treat it with series of catalyst. Very high temperature and pressure, temperature something like 773 Kelvin and pressure 10 to 20 atm, and we take catalyst which has oxides of chromium, vanadium, molybdenum. We heat it over alumina. It isomerizes, rearranges to first form a cyclohexane. It comes closer like this, and then hydrogen is removed to give you cyclohexane. We reach to this, and once we have a cyclohexane, again it dehydrogenates. To give you benzene. So this is known as aromatization, where we get benzene from N-hexane. If we take N-heptane, suppose we take N-heptane, so can you make out what we will get? We will get toluene. We will get toluene under similar conditions. Trimerization of alkyne will give benzene and benzene derivative. Let us take acetylene. This is the bond line formula for 3-acetylene. We subject to catalyst called red hot iron tube. In red hot Fe tube, we have a whole tube made up of iron and which is subjected to a very high temperature, something around 873 Kelvin. And this bond gets here to attach, this bond gets here, and this bond gets here, and what we get is double bond and double bond, we get benzene. And suppose if we have propyne, if we take propyne, this is one propyne, this is other propyne, and this is third propyne. So what will happen is this goes here, this goes here, this goes here, and we have (1,3,5) trimethyl benzene. Also it is known as macetylene. This is benzene sulfonic acid. When you hydrolyze it, you take steam, very high temperature, something around 473, 422 to 473 Kelvin. This HOH, this part goes to this sulfonic part, and this hydrogen part, it goes to the benzene ring, and what you get is benzene plus sulfuric acid.
So guys, that was all about method of preparation of benzene. जल्दी मिलते हैं हम next lecture में for the physical property of benzene.